Flying a single autonomous drone already has its challenges. Now multiply that by 25. That's what scientists at the University of Southern California are doing, creating flocks of coordinated drones capable of intricate, synchronized maneuvers. Their aerial performances are the result of complicated coding and algorithms, which ensure that each drone maintains its own path, avoiding the airspace of its neighbors. The drones are...
In general, if you're trying to solve a complicated task, you have to try to figure out, what is that task? How do you define that task for the robots? How do you break that up into pieces so that each robot can do each of those different pieces? And then how do you ensure that each of the robots actually does the job so that the entire team can be successful? And so what we're watching here is a very kind of successful demonstration of teams of...
Those different tasks could range from things like search and rescue to coastal and border surveillance to wildfire monitoring.
The idea for teams of robots to do things that are challenging for humans to do. Or even impossible. So going into collapsed buildings, an aerial vehicle can, fly through gaps, whereas
the USC team is working to create a simple controller, say via a computer or tablet interface, that would one day allow someone to easily control drones using an established set of codes, turning what are now aerial stunts into real-life applications.
Localizing or knowing where it's at based only on the camera, and then mixing that with its IMU, and that's what allows it to race through here. And it has been trained on individual objects. You're a person, barrels, pallets, signs at 5 meters a second, and it's blurry to us. I don't know that we could actually.
Could you use this technology?
You can look in any direction and do head checks. I mean, I couldn't imagine you driving your car just with them.
Yeah,
这是一台很智能的植保无人机，它让作业变得更简单。每次作业前，拿着遥控器绕着农田走一圈，就能直接规划好航线。下次作业时直接调用数据就可以了。设置好喷洒参数和作业模式，上传到植保无人机以后，就能开始自动作业。操作简单，而且效率很高。我们一天能完成400-500亩的作业。
有的田块不平整。 MGS 配备了3台雷达，飞的时候可以自动定高，完全不用担心掉高影响喷洒质量。最终的喷洒效果是最重要的。MGS 配备了双水泵，可以分别控制前后2对喷头，比 MG 的喷洒精度更高。喷洒速度和飞行速度是联动的，飞行速度不稳定的时候也能做到均匀的喷洒，不会烧苗，也不会漏喷。
那无人机2分钟就可以搞定。 无人机打药
很多，今年我要扩张无人机植保业务，为更多的农户服务。
The increased flight space is not convex, including a work area and a pole that must be avoided. To navigate in this non-convex region, we have developed a novel, fast motion planning algorithm for finding collision-free multi-vehicle paths in the presence of static obstacles. The path planner iteratively adds linearized collision constraints and solves for minimum acceleration paths using sequential quadratic programming. Further, by decoupling the multi-agent planning problem and solving for individual paths sequentially, we are able to generate trajectories in near real time. A software architecture built on the robot operating system allows for easy operation of vehicles, while the path planning algorithm keeps vehicles from colliding with obstacles. The new algorithm finds paths faster and more reliably than existing multi-agent path planning solutions.
This video shows the result of a Raven flight test under the same scenario as the previous simulation. The display window now shows the true vehicle position in real time. As before, the vehicle initially flies straight ahead. Once that path is ruled infeasible, it finds a new path that flies around the column, passing over the stool and by the chair. The blue path is the vehicle's reference input, while the green path is its trajectory. The planner issues waypoints to the vehicle controller. The vehicle controller's job is to track these waypoints as accurately as possible. When the planner expects the vehicle to have arrived at the goal, it is up to the controller to cover the remaining distance. This flight demonstrates the planner's ability to continuously adapt to a changing environment. As before, the large obstacle is moved to obstruct the path to the goal. The planner again picks a path around the column. This time, the obstacle is moved again, clearing a new path for the vehicle. The planner recognizes that this path is better and changes direction.